All right, what we have, I call this our bowling ball pendulum. I have a bowling ball suspended from a cable from the ceiling. And right now it's at its vertical position, which means it's not moving and it has no potential energy. We'll say this position right here is what we call our zero potential energy level. But if I move this back a little bit at some angle, and I let go of it, it's going to start oscillating back and forth. The reason it's oscillating back and forth is because from the bottom point here, when I move it to some angle, it's actually been elevated some distance, some vertical height takes. Not very much, but some vertical height takes. If I let go of it, just like we have an object falling straight down, so it's moving in an arc. All of this potential energy here is going to be converted to kinetic energy at the bottom of the patch. And as it oscillates back and forth, this potential energy at this point is going to be the same as the kinetic energy at this point, which is going to be the same as the potential energy at this highest point here. The potential energy at each point has to be the same because of law of conservation of energy. The total energy along this entire path has to be the same. So if I move this at an even larger angle, it has an even higher vertical distance from where its rest position, so it has even more potential energy. So as it falls, it's going to be speeding up, it's going to be moving even faster at the bottom of this path. We see it oscillating back and forth. You can't see the all the way arc on this side, but we can see it pretty good. Now the thing is, it has to follow law of conservation of energy. The total energy anywhere in this position has to be the same. So what we're saying is, if this object is lifted up to some height at this point right here, all of this potential energy converts to kinetic energy at the bottom, and all that kinetic energy at the bottom is going to be converted to potential energy at the top. So in order for the potential energy here and the potential energy at this end to be the highest, it has to rise to the same height. It can't raise any higher because that would mean it'd be gaining energy and violate the law of conservation of energy. So if I move it to some angle here and some height here, it's going to be at the same angle and the same height on this other side. To prove that, let's do this. Let's say we move this at a large angle and bring it right up to my chin. Now, if the law of conservation of energy is true, this bowling ball will go down and it'll come back, and it should not go any higher than what it is right here. So if I understand the law of conservation of energy, I know this bowling ball isn't going to go any higher than this height right here. So if I let go of it and stand right here and don't move, I know it's not going to hit me. Let's see what happens. It's coming back, and it goes to its highest point. It does not hit me. So that means the potential energy here was the same as the potential energy it had way over that side's highest point. And when it came back, it could not have any more potential energy than what it started with. So it cannot go any higher than this position right here. So it cannot come any higher to that position, and I know it's not going to hit me. I'm not going to flinch. So that's a little demonstration of conservation of energy in our bowling ball pendulum. You should be able to have enough information from yesterday's problem and this demonstration and other things we've done with the pendulum to answer the questions on the quiz.